Hi, I'm Bob Pryor. You probably knew that. Oh, and you are what you eat. At least I've heard it said that way. The order of operations, section 1.6. Number 1, evaluate within all grouping symbols, one at a time, if there are any. And if they're not, don't. Yeah, just wait until they come up. Okay, apply any exponents. Apply multiplication and division reading from left to right. ... I'm not sure what that's about. Apply addition and subtraction reading from left to right. Reading from left to right. So here it is. We've got these operations. Oh, you have read the book, haven't you? You know, section 1.6? Yeah? Because that's what I'm talking about. And I'm going to go over the examples. So I'm assuming you've done the reading because I'm not going to talk about every single thing in here. Right? Yeah, you do that, right? Oh, and be sure to read, after you see this tutorial. It's probably a good idea to do that too. Okay, so we have these different ranks, 1, 2, 3, 4, of the order of operations. Exponents has the second rank, and multiplication and division have the same rank. So when we have them both in an equation, which one do we do first? Is it always multiplication? No, not necessarily. Division might be done first, from left to right. Hopefully we'll see some examples like that. I'm going to start right with example 1. This is on page 2. Example 1. Let's see what we've got here. We've got 6 plus 12 divided by 3 for part A. 6 plus 12 divided by 3. Now it looks as though we should do addition first, but no. No. Addition has the very lowest rank, doesn't it? Division has a higher rank, so we do division first. 12 divided by 3. We don't do them in the order that we read from left to right unless they're the same rank, and these aren't. This is rank, the lowest rank 4. This is, division, it's got a higher rank. We do that one first. Okay. When we use the order of operations, we should apply it one step at a time, and that's what I'm going to do each time here. I'm going to show every step so we can see how things change from step to step. We got the 12 divided by 3, that's 4. 6 plus 4 is 10. Done. We've evaluated. Okay. Let's look at part B. Quantity 6 plus 12. That's what we call when we put in parentheses like that, we call it a quantity. Divided by 3 squared. Here, addition has the highest rank. Why? That's right, because it's in parentheses, in grouping symbols. And that automatically elevates it to the highest rank. So we do addition before we do anything else. 6 plus 12 is 18. I haven't done division yet, so I still write it out. I haven't squared the 3 yet, still write that out. Want to make sure I do things in the right order. Now, I no longer have any grouping symbols here, so I just have division and I have an exponent. And I'm going to make that exponent a little bit larger so it's easier to read. We're going to apply exponents next. That's right. I heard someone say it. That's right. We apply exponents because that's got the second rank and there are no more grouping symbols. So, we don't divide first. No. 18 divided by 3 squared. 3 squared. 3 times 3 is 9. 18 divided by 9. Now we finally apply division and we get 2. Good. Let's look at letter C. It says the square root of 24 plus 6 times 2. 3 operations, really. We have the plus sign and the times sign, but we have this square root symbol, which is both an operation and a grouping symbol. So as a grouping symbol, it says do what's inside first. So we work inside here. And then when we get to the end, we'll try to take the square root of that value. Between addition and multiplication, we do the multiplication first, because that has a higher rank. So notice that in writing this, I do not just ignore the radical sign, the square root symbol. It's the first thing I write down. And then 24 plus 12. 6 times 2 is 12. I'm not going to take the square root yet, got to add together because of the addition inside the square root. So square root of 36. And the square root of 36 is 6. That's right. And that's how we evaluate that one. Okay, the square root didn't come to the very end. Okay, let's see what we have next. Example 2. Do the reading. I'm not going to do all this explanation. I'm just going to go through the motions of example 2. I'm going to erase everything here first. And we're looking now on page 5 at example 2. And on page 4, you're asked to think about things and recognize a pattern. I'm just going to get right to the example, assuming you've done that already. Or if you haven't, then you'll read it afterwards and get it. So here's part A. It says we have parentheses, -2 squared. Now, as it is, we can treat this as something times itself. Anytime you have a number, squared, it's something times itself. And notice that we have a negative times a negative. Negative times negative is positive. That becomes positive 4, or just 4. Could write the plus sign, positive 4, or just make it 4. Compare that with letter B, -2 cubed. This is -2 times -2 times -2. Well, let me go ahead and put some dot here for multiplication. But let me point out that we have already figured out that -2 times -2 is positive 4. We've already figured that out. And now it's being multiplied by that other -2. And positive times a negative is negative, and that's -8. Okay? Another thing we might recognize is that a negative times a negative is positive, times one more negative is negative. And figure out that it's negative first. And then figure out that it's 8, so it's -8. In fact, look at this. -2 to the 4th. -2 once, twice, 3 times, 4 times. I was about to sing. Did you notice that? I don't want to sing right now. You don't want me to sing right now. Anyway, negative times, basically it's one more -2 times the -8 that we had from -2 cubed. -2 to the 4th is that same number, -8, times -2. Negative times negative is positive 16. That time I wrote the plus sign. Didn't need to do that, but just for emphasis, you know. I'll let you do letter D on your own. Works out very similarly. Here's letter E, though, -2 to the first power. Anything raised to the first power, whether it's positive or negative or even 0, anything to the first power is itself, the base, -2. So there's that. Letter F, letter G, letter H. It's just a matter of multiplying these numbers out. Let me just do letter H. It says we have -9 cubed. Well, we can decide that -9 times -9 times -9 is a negative number. But what negative number? Well, think of it as these two multiplying to get positive 81 times -9. To figure out the number that goes here, we have to multiply 81 times 9. So I'm going to do that off the side of scratch work. 81 times 9. 1 times 9 is 9. 8 times 9 is 72. There it is. -729. 729. Okay? That's example 2. Good. Erase all this. Yes. And we're going to look now at example 3 on page 6. And again, I want you to do the reading because there's some stuff that I'm not necessarily talking about here. I'm assuming you're doing the reading. Here's letter A. It says evaluate square root of 36. Simple. It's 6. In fact, we did that in one of our earlier examples just a minute or two ago. Square root of 36 is 6. What happens, though, when the negative is on the outside? Well, order of operations, right? Yeah, that's what we're in here. Evaluate within all grouping symbols. That means we evaluate the square root first before we negate it. The square root of 36 is 6, and then it's being negated. So this is negative 6. Now I do want to expand on that just a little bit if you don't mind. You might recall that, in fact I'll write that down. Recall x, x can be thought of as 1 times x, right? Yeah. And negative x can be thought of as negative 1 times x. So the coefficient of negative x is negative 1. Coefficient of x is 1. We call this sometimes the invisible one, and we make it visible. So here it is visible. Well, if we treated this the same way, we treated this as negative 1 times square root of 36. Again, order of operations would prevail here. Take the square root first because it's like a grouping symbol. We do that first. And that's 6. So what we're really looking at here is negative 1 times 6, and now we can finally multiply, which gives us negative 6. So that negative outside is not done first. In fact, it's very patient and waits. Okay? And letters C and D are very similar. So I'll let you look at those. Okay? Now, there is one thing, and I'm going to keep this page right here and just draw a line. We're going to move on to page 1.6-7 and look at example 4. This time, we're going to see something similar but different. Definitely different. It starts off just the same way. A, square root of 36 equals 6. B, negative square root of 36 equals negative 6. Now, here's the thing that's different. C, the square root of negative 36. You know, 6 is a square root of 36 because 6 times 6 equals 36. And actually, we call negative 6 a square root if we multiply this times itself. Negative 6 times negative 6. Just off to the side, let me hear it. Negative 6 times negative 6. That's 36 also. But when we have a negative inside, there's no number all by itself that will multiply. No real number that will multiply to get negative 36 when it's multiplied times itself. It'll never be a negative, right? Because a negative times a negative is positive, and 6 times 6, positive times positive is positive. We call this undefined. Now, consider letter D. There's a negative on the outside and a negative on the inside. But the truth is, just like over here, we couldn't do anything with that negative on the outside until we found the square root of 36 first. Once we found that that was 6, oh, it's negative 6. Well, we can't do anything with this negative outside until we can evaluate this. But this can't be evaluated. Like up above, square root of negative 36. When the negative is inside the radical like that, when it's inside for a square root, it's undefined. So we never even get a chance to use this negative. It's still undefined.